Okay, good morning. Welcome to IJCAI 2015. We're delighted to welcome you to the 24th International Joint Conference on Artificial Intelligence. This is the first in a series of press conferences. We'll be having a press conference every morning throughout the rest of the conference until Friday at the same time, just half an hour to introduce you to some of the highlights of the conference. Let me introduce myself. My name is Mike Aldridge. I am a professor of computer science and head of department at the University of Oxford in the UK, and my role here is that I'm a conference chair for IJCAI. So what I want to say a few words about is just firstly what artificial intelligence is. And some of my esteemed colleagues in the room may have something to say about my thinking about the subject. And then I'll say something about what IJCAI is and why this is such an exciting time for AI researchers. So when I was a teenager, it was still routine to describe computers as artificial brains. That was the kind of terminology that was used to describe computers. And why did people call them that? Because computers are very good at some things which people find difficult. What are they very good at? They're very good at, for example, doing large amounts of very, very simple computations, decisions, very, very reliably. And that's something that people find tremendously difficult. But it turns out there are many things that people find extremely easy and routine that turn out to be tremendously difficult to get computers to do reliably. So what do I mean? So some examples are understanding ordinary conversations and stories. Turns out that computers find it very, very hard to do that. Driving cars, riding bicycles, things that we can do without, it seems, any real formal training. Computers find it very difficult to do. Recognizing faces in a crowd. Playing a game like Angry Birds, and we'll hear some more about that later on. And then there are some deeper issues about that seem to distinguish us as individuals, things like consciousness. Can we build computers? Can we build machines that have consciousness? And AI is really about getting computers to do these kinds of things. And issues like consciousness are still some way off, but over the last 2 decades we've seen tremendous progress in all of these things. And what we're going to hear about over the next 20 minutes is some examples of the progress that's been made. Why has progress been so swift in the last 2 decades? There are a number of reasons. There are scientific breakthroughs, but also it's the availability of large amounts of data provided by the World Wide Web, and the fact that computer processing power is now much cheaper than it ever has been. Okay, so what is IJCAI? Well, since 1969, IJCAI has been the main forum for presenting scientific research results in the area of artificial intelligence. It's been held, roughly speaking, every 2 years since 1969. 2015 is the first time that the conference has been held in South America. The conference rotates around the world, typically between North America, Europe, and the rest of the world, but this is the first time that it's been held in South America, and we're tremendously happy to visit Buenos Aires. This is a record-breaking conference. There were 2,000 scientific papers submitted to the conference, and each of those papers received 4 peer reviews by scientists working in the field to evaluate how good that paper was. And less than a third of those 2,000 papers submitted were actually accepted for the conference. There are nearly 100 associated events attached to this conference, and we have 1,300 delegates visiting the conference from all across the globe, from every continent. So this is really a boom time for AI, because there have been these tremendous breakthroughs in the last 2 decades. And if I have to identify just one breakthrough work that you should go and look at, one item that you should go and look at, I would point you at the invited speaker Julien Cornebis from Google DeepMind. Google DeepMind is the London-based AI research lab for Google, and DeepMind was acquired by Google for $400 million in 2014. So incredible sums of money being invested into this technology. And if you want to understand why Google thought $400 million was worth investing in DeepMind, I suggest you go to Julian's talk. He's got some great videos. It's really exciting stuff. It's at 2 p.m. today. And he's going to tell us what DeepMind is and why the work that they're doing there is so exciting. And you'll get a feel for what what those breakthroughs are and what the future holds for us. Okay, so we've got a couple of other short presentations by some colleagues. So Joachim, are you ready for Angry Birds?
I thought it's not my turn yet, is it?
Okay. How about we have a presentation on... Sorry?
Christoph is there.
Ah, Christoph. I beg your pardon. Christoph?
Hi, morning.
Do you want to come up and say a little bit about consciousness?
Sure. Thanks, Mike. So consciousness has been one of the oldest philosophical problems in rational thought. And by consciousness here, I simply mean the fact of having experiences, whether you are the feeling that you are you, or the feeling that you are happy or in pain or seeing color. Those are all different aspects of consciousness. And the questions, of course, has been forever, can we have an empirical based theory of consciousness that's amenable to test, or is this going to be forever a problem that remains beyond the bound of science? For the last 40 years, there has been major progress in the mind-body, in this particular aspect of the mind-body problem, in the sense that people agree we can all study what's called the neuronal correlates of consciousness. In other words, we can study in humans or in closely related species, we can study what parts of the brain are specifically involved in having conscious experience, as compared to what part of the brain are involved in generating behavior that may or may not be conscious. And of course, we know since Sigmund Freud that most of our behaviors involve and for most of our behavior, consciousness either comes after the fact or isn't involved at all. So it's a separate research track in the brain sciences, in the clinical sciences, trying to identify in humans and apes and a few other related species what are the specific areas of the brain that are involved in consciousness. Now, even if that program ultimately comes to a successful conclusion, as there's no reason it should, I mean, it's a standard scientific problem trying to identify which part of the brain are involved in generating conscious perception, that doesn't answer some of the more fundamental problems around consciousness, namely, what is it about any physical system that gives rise to conscious experience? What, for example, does this thing here, does this iPhone have conscious experience? Does a newborn baby have conscious experience? Does a fetus have conscious experience? Does a patient who's severely disabled have consciousness? Does an animal whose evolutionary and structural similarity with us is quite different, let's say an octopus or squid, it's very different, it's capable of very complex behavior, does it have consciousness? What about bees? Or what about group mind? Right? There's been forever theories that claim that group mind, for example, the beehive that consists of 10 to 20,000 bees by themselves, has some consciousness. How can we ever how can we understand questions like that? In particular, of course, now with the rise of AI, we're being challenged by systems that behave like if they had consciousness. So certainly, if in a patient, you talk to a severely impaired, neurologically impaired patient, and the patient could drive a car, or could play chess, or could answer any of a large number of questions, there would be no doubt you would say that the patient is conscious. So how can we deny consciousness to systems, to artificial systems that have those behaviors, but that have, of course, a very different, a radical different underlying circuit and evolutionary history. So what this calls for is a general theory of consciousness that tells us what are the general conditions formulated in a relevant mathematical language, the language of causality and of information of Bayesian networks? What is the general theory that tells us which system can and cannot have consciousness? And the dominant theory there is a so-called theory of integrated information by Giulio Tononi, an Italian-born American neuroscientist and psychiatrist. And it comes to a number of surprising conclusions. So one of the things that it gives rise to a number of testable predictions as to how you can measure consciousness in people, which is actually not an easy thing, particularly trying to measure consciousness in patients that is severely impaired. So right now we don't have what's called a conscious meter. We don't have a reliable way to measure whether this patient in front of me, who may be paralyzed, who may be severely traumatized because she's been in a car accident, and who may just groan or have some rudimentary behavior, to what extent this patient can be conscious. But the theory now gives rise to tests where you can measure the presence of consciousness in this particular patient. The theory also comes to some surprising conclusion with respect to consciousness. So it avers quite clearly that any simple, consciousness depends on the circuitry of the underlying brain. And if the circuitry is of a particular of the type that's present in these deep convolutional networks that were already mentioned, which is sort of the standard tool right now in AI. These are feed-forward networks. They can be very, very deep, up to 20 or 30 layers. That such a system will not have consciousness, which gives rise to the surprising conclusion that the absence or presence of consciousness cannot be detected by a simple Turing test. Right? That the Turing test is more a test about social psychology, to what extent can you get people to accept an artificial creature like Ava in Ex Machina, or Samantha in Her. To what extent will people accept that this person is sentient? That doesn't answer the question, is that person actually sentient? So the theory says that you have to look at the circuitry, that certain types of systems that display complex behavior equivalent or possibly even superior to that of a human, may not be consciousness. In other words, it dissociates consciousness from intelligence. That's really the key message, that those are really two different things. That you can have a system that behaves intelligent in a complex world, including learning, but the system may or may not have any conscious experience. In other words, you could have sort of a complete zombie, or what philosophers refer to as a zombie, a system that acts as intelligent as you and I, but that doesn't have any conscious experience. And I'll be talking about that.
Okay, thank you very much, Christoph. Okay, next we're going to hear a description of some work where AI technologies have helped to improve lung transplants.
Good morning, everyone. I'm a student from Tsinghua University from China, and Ping Yongtang is my advisor, but he did not come here today. So it is my great honor to introduce our work here. So let me begin with the story about the kidney exchange. The patients who suffer from kidney disease will die in months. One treatment option is dialysis. The quality of life on dialysis can be extremely low. Only 12% of dialysis patients survive 10 years. Kidney transplant is a better treatment, but unfortunately, the demand for kidneys far outstrips supply. So the best option is to find a living donor who is willing to donate one kidney. Frequently, the intended donor is incompatible with the patient. Such incompatibility can be overcome by an exchange between the patients and the donors. Kidney exchange became widespread in the last decade in the United States. Elvin Rose, who has proposed the mechanism designed for kidney exchange, has won the Nobel Prize in Economics in 2012. Thomas Senholm, a professor from CMU, has built up the United Network for Organ Sharing System, which includes 60% of the transplant in the US. And this is the background of kidney exchange. However, even though the living donor lung transplant is introduced more than 2 decades ago, lung exchange has never been systematically explored until recently. A healthy human has 5 lung lobes, where 3 lobes are in the right and 2 lobes are in the left. In the lung exchange system, a patient who suffers from lung disease needs 2 donors to donate. Each to donate a lower lobe. The first successful case of living donor lung transplant in China was in 2009. The parents each have donated one lobe of lung to save their kid's life. There are about 60 lung transplants per year in China. Our work formulates the land exchange problem and formally proves that it is computationally harder than the kidney exchange problem. We then put forward a mechanism that always returns an optimal exchange while enjoying desirable economic properties. Using advanced AI techniques, we give an integer linear programming algorithm and a search algorithm to implement the proposed mechanism at practical scales. Both kidney exchange and land exchange are the prominent cases of barter exchange. In this market, people swap their items without money. In most countries, it is illegal to buy and sell an organ from human. So organ exchange is a successful story as a barter market in economics. And in the medical perspective, the demand for deceased donor organs far outstrips supply, and not all willing donors can donate to their intended patients due to the medical incompatibility. Organ exchange is a supplementary source for organ transplant, and it is a method to overcome the incompatibility. So at last, I want to make an advertisement here. The research interests of our lab are in multi-agent system, mechanism design, including option design, matching, and practical market design. So welcome to China, and welcome to visit our lab. Thank you.
Thank you. Okay, next I'm very happy to introduce Jürgen Renz, who's going to say something about computers playing Angry Birds.
Hello, so I'm Jürgen Renz from the Australian National University, and I'm the organizer of the Angry Birds AI competition that has been held since it's the 4th time this year. It's been held every year, and the task of this competition is to build computers that can play Angry Birds as good as humans can, and specifically to play new levels of Angry Birds, unknown levels of Angry Birds that are as good as humans can. Because if you know a level, you can practice, and then of course you can, for example, reprogram the best shots. But that's not the task. So what I want to tell you today is a bit about the competition, why it is hard, the problem, and why it's an important problem for AI to solve. So first of all, the competition is this week for the 4th time, and on Thursday is the day when all the AI agents compete against each other, and there are different stages of the competition until we have the grand final, which will be at 6 p.m. on Thursday evening, and I believe it will be in this room here. And then the winners of the AI competition, they can be challenged by everyone who wants to come on Friday. So on Friday is the Man versus Machine challenge, where we test if we've reached our goal that the AI is already better than human players. So everyone can come and see if they are better than the AI. So we will, during the whole day from 10 to 6 in the evening, humans can play here, and at 6 in the evening the AI is playing, and then we see if they are who's better. So that's the big challenge. So now, why is this a hard problem? Why is it even an interesting problem? Why? So when you think about it, much of AI and much of the AI successes that we've seen so far, they are kind of inspired by the Turing test, right? So it's very much virtual AI. You sit in front of the computer, the AI is in the computer, and you're dealing with AI in the computer. And most of the AI successes that we've seen so far, they are very good at these kind of things. But when you think about it, when you interact with the physical reality, when you interact with the world, and that's what we're seeing more and more, that computers and robots are entering our world. What they have to do is they have to deal with the real world, they have to deal with the physical consequences of their physical actions. And in Angry Birds, it's exactly the same. You make a shot, you hit the structure that protects the pigs, and something is going to happen. But the problem is, you have no idea before you make the shot what is going to happen. So humans, we are very good at estimating and predicting what's going to happen. So this year, you probably cannot see it on the video, this is my favorite Angry Birds level because this involves a lot of reasoning. So people have to, and computers have to analyze this level and see what are the consequences of our actions and what's going to happen if I make this shot. So basically, computers are not able to simulate a level in advance because they don't know all the physics parameters of the world. They only know what they see. So they play the game like we play the game, they look at it, they only get screenshots and have to use computer vision to analyze the game. So they cannot simulate a shot. But even if they could simulate the shots, they would have to look at almost infinitely many possible shots in order to determine the best shot, or the shot that they want to do, the shot that has the consequences that they want to achieve. Or take this to the real world, what robots should basically do when they interact with the real world, they should pick their actions so that there are no unintended side effects. So they don't want to accidentally make something fall over or break something or accidentally hurt someone. So that's what robots and AI that's interacting with the physical world needs to want. So now why is it important? You could already guess. So it's because this is what robots have to do. They have to choose their actions so that no one gets hurt, that no unintended side effects, nothing breaks. And I was telling you in the beginning that much of AI has been inspired by the Turing test. So what I'm proposing is a new, a more modern and maybe more practical version of the Turing test. It's basically, can we build AI that can interact with the physical world as good as humans can? And which means that they pick their actions so that no one gets hurt, no unintended side effects, nothing breaks on their way. And Angry Birds is the first step towards reaching this goal. Thank you very much.
Okay, thank you, Joachim. And finally, I'm very pleased to introduce Stuart Russell, who's a computer science professor at the University of Berkeley, a very long-established and well-known AI researcher. Stuart's going to talk about how the AI community is responding to concerns about the possibility of artificial intelligence systems making decisions in situations that we might not be entirely comfortable them making. And in particular, the possibility of autonomous weapons. So, Stuart. It's the usual. Try again. It knows it's dead. Good. Okay. So what I'm going to talk about is the issue of lethal autonomous weapons systems, sometimes known as killer robots. So that term, killer robots, has been used widely in the press, and it's the name of the campaign to stop killer robots. The name killer robot actually upsets some AI people because it sounds as if we're building robots, we the AI community are building robots to kill people, or that robots could just turn into killer robots overnight. So neither of those things are really true, but there are very significant developments in the area of lethal autonomous weapons systems, you might see in the media claims that, although this is 20 to 30 years in the future, or this is a subject of science fiction, this is actually very real. There are already autonomous weapons systems that can attack and destroy facilities, and if those facilities contain humans, then they will be dead. So
as the process of moving our warfare systems from purely human-driven to a mixture of humans and robots, as that process has unfolded, it's been part of the US policy now for about 15 years that we should move the US Armed Forces to at least 1/3 of all vehicles being autonomous vehicles by, I think, 2020. So this is a very, very serious and very large-scale development. So one of the things that people worried about was, is it right to have machines deciding who to kill and deciding to kill them? The US formulated a policy in 2012 which says that appropriate levels of human judgment need to be involved in any decision to attack humans. Unfortunately, it leaves open the definition of appropriate levels of human judgment, and it also allows for the possibility that under certain circumstances the directive can be overridden by the Secretary of Defense. So it's not a very strong policy, but it is a guide. In 2013, Christoph Haynes, who's a special rapporteur on extrajudicial killings and torture, produced a report analyzing the possibility of autonomous weapons and saying that they are an affront to human dignity and they open the possibility of violating human rights on an enormous scale, and therefore we should work towards a ban. In the same month, the campaign to stop killer robots was launched. That consists of about 15 international organizations, including Human Rights Watch, which is one of the leading human rights organizations in the world. Last year, the United Nations convened formal meetings at the Conference on Disarmament in Geneva, which is the venue where arms treaties are debated and formulated and eventually signed by the member nations of the United Nations. So there have been 3 meetings so far, and those meetings have discussed potential definitions. They've reached, I would say, a consensus that meaningful human control needs to be applied in the use of weapons. But they have not yet reached the stage of drawing up a treaty or convening what's called the Group of Government Experts, or GGE, which is the formal stage where we begin to write definitions of the technical terms and then start drawing up the content of a treaty. On the side of the AI community, I would say that the community and its representatives, its professional organizations have been a little bit slow to catch up with these developments. So arguably we should have had this meeting 10 years ago and been thinking hard about this and reaching conclusions about whether this kind of thing is a good idea. The implications for the AI community are enormous, because if AI systems are out there on a mass scale being used in warfare, then this would be the most prominent application of artificial intelligence in the eye of the public of the world. And that might not be a good thing for the field. So it's clear that there are very high stakes here, not just for the AI community, but also for humanity at large. So in 2015, in January 2015, there was a debate at IJCAI conference in Austin, Texas, and Steve Goose from Human Rights Watch and Ron Arkin from Georgia Tech talked about the issues on both sides. A very honorable debate. The goal of the campaign to stop killer robots, which Steve Goose is a member, is really to get the professional associations to adopt a policy in opposition to autonomous weapons, in order that this could then provide some momentum in the discussions at the United Nations. It would provide more political pressure on the nations to actually move ahead and reach a decision on a treaty. So after the talk that I gave at the United Nations in April in Geneva, I wrote an editorial in Nature which explained my position, and I'll say in a little bit exactly what that position is. And then Since then, FLI, which is the Future of Life Institute, an organization at MIT and Harvard, took that letter and turned it into an open letter, which is available for everybody in the AI community to sign. So let me just bring up that letter. So this is the address, futureoflife.org/AI/open letter autonomous weapons. And as you can see, it was embargoed until this morning, but several news organizations were already publishing articles about this yesterday, starting with The Guardian. And what the letter says is that although there are arguments on both sides that autonomous weapons could perhaps be more accurate and kill fewer civilians in some particular circumstances, and on the other side, it may be a fundamental devaluation of human life and dignity if machines can decide who to kill or whether to kill you in particular. For us, the primary argument was to look at the endpoint of an arms race. So if there is no treaty, there will almost undoubtedly be an arms race in autonomous weapons. And the endpoint of that will be the availability of very large numbers of autonomous weapons that are extremely lethal. So you can think of, if you imagine small autonomous quadcopters, these can be reduced to a very small size, the size of a large beetle, and still carry enough explosive to blow a hole in somebody's head. And then swarms of those, they're going to cost, not much more than a bullet. And then enormous swarms of those, by the tens of millions, could be dropped on cities and used to wipe out entire populations. They could be dropped on cities and used not to wipe out, but just to terrorize entire populations. So they can be commanded to patrol and fly around and eliminate any signs of dissent or unrest, for example. So it seems inevitable that they would be used, and used in ways that would render human life almost valueless in large parts of the world. So our view is this is a terrible potential outcome for the human race, and we're better off with a treaty that would control and, in some circumstances, ban the development of these weapons. So right now, as of about 10 minutes ago, we have about 5,300 signatories, and of those, almost 1,500 are AI researchers from more than 50 countries. There are 6 past presidents of the IJCAI, which is the Association for the Advancement of AI. We have the current and former president of the IEEE Robotics and Automation Society. We have the current and 2 former presidents of IJCAI. We have senior directors from Google, such as Demis Hassabis, who's CEO of Google DeepMind, Jan LeCun, who is the research director of Facebook, again, one of the leaders in deep learning. We have Eric Horvitz, who's the managing director of Microsoft Research. We have Steve Wozniak, Elon Musk, Stephen Hawking, Noam Chomsky, and a number of other famous philosophers and physicists and other scientists. So just since yesterday, this has gone up by about 3,500 people have signed just since yesterday. So the letter has been public now since the announcement, since the article came out in The Guardian, and that's led to a very large number of people signing. Okay, so I'm happy to take any questions if people have them. Yes.
So in the public mind, who speaks for AI? I mean, you hear Steve Hawkins, you hear Elon Musk, and you hear Bill Gates, but who speaks?
In the public mind, who speaks for AI? I think there's a vacuum. There is a panel discussion on Wednesday afternoon called Who Speaks for AI? this is in fact one of the reasons why I've been advocating that we should have a single international organization that represents the field. Because this is an area where nations are looking to the field for guidance. They need information. The amount of misinformation or just lack of information out there among diplomats, among the press, among experts on international relations is staggering. So many of the disarmament organizations begin their statements by saying, although these weapons are 20 to 30 years in the future, blah, blah, blah. But if you ask the Ministry of Defense in the UK, they'll say these weapons are feasible now. So there's a huge gap in understanding of what's really going on. And so I've been arguing that this is the kind of area where a single international organization would have been extremely helpful. And the sooner we have one, the better. Other questions?
Okay, thank you, Stuart. So that pretty much concludes this morning's press conference. There'll be another press conference tomorrow morning at 8 AM. Serious food for thought in Stuart's presentation there. Issues that the AI community is taking seriously and addressing, and we'll be discussing those throughout the remainder of the conference. But we've also seen how AI technologies can be hugely beneficial in facilitating lung transplants and saving lives. And there are just as many positive, if not more, positive examples where AI technology is benefiting society and humankind as there are these areas for concern. So that draws to a conclusion today's press conference. Thanks everybody for joining us.